Hi, my name is Daigle. So, let's start by considering two different systems, the steel production system and wind turbine power generations. At first they seem sort of unrelated, but if you consider that wind turbines are made out of steel, it makes a little bit more sense. So what do we know about wind power? Wind power has a very low carbon impact. From a life cycle analysis, coal-fired power plants contribute up to 1,000 grams of carbon dioxide per kilowatt hour energy produced. Oil and natural gas are a little bit lower, about 6 to 700, and renewable power sources are sitting at about 50 grams of carbon dioxide per kilowatt hour for solar power and under 30 for wind. So we can say that wind power is good for the environment. So why don't people use it? The number one reason is its cost. Wind power costs about 11 to 13 cents per kilowatt hour in Ontario compared to a current cost of electricity of about 7 cents. To increase the feasibility of wind farms, we need to reduce the price. If we can reduce the carbon footprint at the same time, double win. So, where does the cost of wind turbines come from? The primary cost and greenhouse gas contribution for wind turbines is manufacturing and installation, mostly because of their size. Wind turbines are pretty big. So, how does the steel industry help us? The steel industry has been around for a long time. Union Steel in Hamilton was built in 1912, over 100 years ago. Because of its age, technology hasn't been upgraded in a long time. It's running on ancient things. The cost to transport steel and to make a new steel manufacturing plant are incredibly high, so there's fairly small competitions between different companies to improve techniques optimizing energy and carbon intensity. This leads to a wide range in energy intensity from 18 to 38 gigajoules per ton of steel produced. So what if we can cut this number down to 7? Over 80% in efficiency increase and carbon reduction by over 400% with a single process. Well, we can't. Commonly, steel is manufactured by taking raw ore, putting it in an oxygen blast furnace, and blasting it at high temperatures with coal, oil, other natural gas, producing a lot of heat and a lot of carbon emissions. A less common manufacturing process requires an electric arc furnace. It intakes recycled steel primarily rather than ore, and passes very high current through it. This melts the steel into a molten state, which can be used to recycle it into different shapes. Electric arc furnaces are powered off electricity rather than renewable coal, oil, natural gas, which reduces the greenhouse gas output by up to 400%. They have the downside of requiring recycled steel, which can be an upside as we'll get back to later. The energy intensity of an electric arc furnace may be easily optimized to be under 7 gigajoules per ton, or 80% increase. So, let's consider building a farm of wind turbines. The average lifetime of such farm is 25 years and has almost no carbon footprint compared to other energy sources. Over the lifetime, the wind farms will produce a lot of energy, which can be used to power more electric arc furnaces. Electric arc furnaces produce steel in a renewable fashion. So the steel produced can be used to build more wind turbines, which can power more electric arc furnaces, which can produce more steel, which can build more wind turbines, and I think you get where this is going. So what happens at the end of the wind turbine's life? They're made nearly entirely of steel, so we can recycle all of that steel using our electric arc furnaces. This turns them into whatever we want, but ideally more wind turbines. So wind turbines and electric arc furnaces create this duality of a positive feedback loop of clean renewable energy as well as clean, efficient sources of steel. Thank you.